Yes, we can hear you.
Okay, so I'm going to start describing a little bit what is the EGI Datahub and the main use cases. So giving an overview also of the Onedata technology, which is the technology that is behind the Datahub. And then Łukasz is going to describe the advanced use cases and new features, doing a live demo of the new functionalities, like the new web interface and the tokens that are behind the Datahub, and the harvesters, and then the quality of service supports. And then, as Giuseppe said, we're going through the last part of the webinar with the question and answer. So describing what is the Datahub. So this is a service that is based on the Onedata technology, and this is co-founded by the EOSC project. The main feature is that it allows transparent data access for data under a common namespace, regardless of their location. This can be access of open data or access restricted to members of particular virtual organizations. The ability of the service that you can access data either via web interface or via API, and that allows the replication of data between data providers, and this is done mainly for resiliency and availability purposes, and can be done either on demand or automatically. The service can be integrated with the rest of the EGI components, and also with the existing infrastructure, user community infrastructure, because it has been integrated with the EGI check-in service, which is the EGI authentication authorization infrastructure service. The components behind, as I said, is based on the Onedata, and which is basically it is mainly divided in different components. So basically, we have one zone that is the service which provides the federation authentication, and is the service that is connected to the storage and provided SSO with the storage providers. The OneProvider, which is a component which performs the data management and is deployed in the different data centers, and it allows provisioning of data, and it is managing also the transfers. This is done using either REST or CDMI APIs. We have also a concept of a space, which is a virtual volume where the users can organize the data. And the space can be supported by one or multiple OneProviders. And another important component is the one client, which is the client providing access to the spaces through a fused mount point. So you can have local POSIX access connected to the space via this component. So graphically, the architecture of the service is as follows. So basically, you have the one zone component, which is the one that's integrated with the EGI check-in service, and it's the one that performs the user authentication. And the different OneProvider are connected to the one zone, and users can create data spaces on top of the different OneProviders. So, and basically spaces are supported by one or more OneProvider. And then we have the clients, which, as I said, can be either fused clients, which they use one client in order to mount the OneProvider to access the data locally, or HTTP clients via REST or CDMI. The data, of course, are copied between the different OneProvider for data balancing and for data transfers. So this third-party copy within the different OneProviders. The service status, the service is provided by EGI Open Service. There is an instance that is available at Datahub EGI.eu, and this is operated both the one zone and the default OneProvider by CYFRONET. As Giuseppe said before, the service is in the transition to the beta phase. So basically, soon as after being promoted as beta, will be part of the EGI service catalog and marketplace. So it will be possible to order the service via our marketplace. And at the moment, it is used by early adopter projects from the EOSC. And during this period of the EOSC project, has been performed the integration with the EGI ecosystem, which is ongoing and almost completed. So as I said, the integration comprises the integration with the IAI, so the EGI service has been completed. Integration with the monitoring help desk is been set up for a particular support for the service. Accounting is something that it will be ready before moving the service to production, but it's something that is being worked on. And there is, of course, documentation available both for the users and the providers. The service offering at the moment. So basically, if you access the service now, everyone has access to a public space, which is named Playground. As the name said, basically it's testing public space where you can do evaluation of the service. Of course, this is just for the functional testing. So there is shared storage space with limited space, but this could be enough, to evaluate some of the functionalities that are available through the Datahub. And of course, users are also available. Have also a possibility to log into the service from the graphical interface, create private empty spaces, and then decide if install OneProvider by themselves or ask for storage support to the EGI. So there is possibility, for instance, to install OneProviders on your infrastructure to store or export a status set, or there is a possibility to contact EGI support and request storage from the EGI Federation providers. This, of course, this will go through a agreement with a SLA agreement with the providers, the process that we always do in case of this kind of services. And there are also communities that may decide to have customized and dedicated Datahub installation for the use cases. For instance, one recent installation has been done for the Panos project, which is available at this address that I put in the chat, in the slide. And of course, if any communities decided to have a dedicated instance of Datahub, they can contact the EGI support in order to have discussions and to discuss the installation. So this is the first screen that you will see when you connect to the service. Basically, they have the possibility to navigate through the spaces and understand, what are the providers that support your space. You have the possibility also to create empty spaces from this first interface that you will see, and to ask for support for different providers that, as I said, you may install, or we have to understand if possible to have in our federation. Once you have chosen one of the spaces, basically you can connect from the same graphical interface to the OneProvider, which is providing the space for the storage for the space. And for each space, users can do usual file operations, so that the usual file operation that are supported, so uploading file, deleting, create directory, and another feature that from this interface that you can do is to share publicly the folders. So basically, if you decide that one of the folders can be shared publicly without authentication, you can do it directly with this via this interface. And the shares can eventually be published via a rental service and have also a person identifier assigned. For instance, this is one of the person identifier assigned to one of the folders that are available in Datahub. Actually, this is a rental to a video with basically you can see how to perform this operation. It is possible also from the graphical interface, but also via REST API to perform a data management operation. So for each file, you can associate metadata in the form of key value pairs or JSON or RDF. This is possible also via REST API to create indexes that are queryable via REST as well. And we have also the service offer also an IPMH interface for metadata harvesting. This is I put on the chat on the slide also the link to the IPMH interface that is available on Datahub. From the interfaces, it's possible also to perform management of replicas and transfer management. So basically, if the space that you are accessing is supported by multiple providers, you can adjust data distribution from deciding, to move data between the providers that are supporting the space for migration purposes or for data balancing. And this is possible to transfer the transfers from the same interface can be scheduled, monitored, and canceled, either as said from the web or from the REST API. As I said, one of the main features is also the possibility to have POSIX access to the data via Fuse. So basically, OneProviders can be mounted and accessed locally to a Linux system. This is possible using Onedata tokens. that are needed in order to authenticate the user access. These tokens can be either generated from the graphical interface, or there is possibility to generate them via REST, contacting the Datahub REST endpoint. This is possible by using one of the access token coming from the EGI check-in, which itself can be retrieved via CLI. So from the command line interface, basically you can first retrieve a check-in access token, and then using the EGI check-in access token to retrieve a Onedata token that is needed in order to access a Monte space. As I said before, also the client that is implementing the access via Fuse is the one client. This client can be is either installed as a package, so there are different distribution available for Debian, Ubuntu, and CentOS. But it can be simply installed also inside a Docker container or run as a Docker container. There is a possibility also to download the one client's Docker image. The main feature that is available using when you mount OneProvider via one client is that if you try to access a file which is not available on the provider that you're mounting, but the same file is available on another OneProvider that is supporting the same space, the file is transparent in transfer, and then can be accessed from the local mount point. Another possibility from the clients is the possibility to use OneDataFS. OneDataFS is a plugin, Filesystem plugin, which allows to work with Onedata as any other supported file system of this nature. This is possible to install via PipeEye and Anaconda, and is particularly useful, for instance, in the case of data access via Python Jupyter notebooks, where you can basically, from inside the Jupyter notebooks, browse the space, open files, and perform the operation that you would do, for instance, using a REST API or mounting locally the space. As I said before, there is possibility to install OneProvider to support EGI Datahub. This is possible, easily possible from the graphical interface. Basically, you can retrieve a one-line installation script, which can be run directly on your server, supporting, as I said, the different distribution and Docker. The installation script will automatically install certificate via Let's Encrypt, and the list of supported backend is quite large. So we have POSIX, Swift, Ceph, ClusterFS, NFS, and WebDAV. And with the same component, it is possible to expose a 16 dataset. In this case, when installing the OneProvider, you would like to expose your dataset to the EGI Datahub. There is possibility to select two options, which is the one-time import of all the data, or the continuous synchronization of the dataset that you would like to expose with the OneProvider. And from the admin panel of the OneProvider, it's possible to have statistics live of the import process or the synchronization process. It is possible also to, from the admin panel, to enable the file popularity. So this is so basically admins can enable the file popularity, and user can query this information via REST API. And in the case of caching the scenario, so when the provider is used as a cache, you can enable the auto cleaning. This feature that can clean the space that is used as a cache based on some attributes, for instance, the free space available, the number of file accesses, or the file access time. The different use cases, as I said before, are supported. One of these is the federation of service providers. So you can have like different service providers supporting different backend, and users can access them using common interfaces and a common API with the EGI check-in. It is possible from the service discovery dataset directly from the Datahub, which can be published optionally with a person identified assign. And for this particular use case, there are different community pilots that are under testing, or they're being set up at the moment. So Maris is testing in this with Sedinata files, and emphasis is going to install a similar infrastructure for plant phenotyping images. There is also, as I said, the use case of the smart caching for the most storages. So imagine that you have a different site, one site with the hosting data sets, computer resources, another site which is providing data, and you can access, for instance, from another site, the data coming from the different OneProvider, either without prestaging of the file or prestaging of the file using APIs, and the access is done via POSIX APIs through VFUs. And then there is possibility also to perform integration with the EGI notebooks. So you can have the possibility to access the database space from the EGI notebook installation, either locally mounting the spaces to the EGI notebook machine, or using the Onedata FS API in case you're using a Python notebooks. There is also possibility to store notebooks directly on Onedata space, which is another use case supported. At the moment, this particular exploitation of the integration between Datahub and the notebooks is performed by the different communities. We'll describe a little bit the PANOSC, and then ECAS has already done the integration, and Brifar is under setup. The PANOSC pilot, PANOSC is a project where EGI is participating, and they deployed a separated instance of Datahub. We deployed a separated instance for Datahub for them, basically in particular because they need to integrate the Umbrella ID, which is the community AI system for their project. And then basically using the EGI notebooks integration with Datahub, is possible to directly from the notebooks read the HDF files and store simulation results from and to OneProviders on top of their community servers via NFS. I put also the link of the Pinot that has been set up. Okay, so I think that for this introduction, I completed my introduction part. So now I will leave the floor to Łukasz for the demo of the new functionality, as I said at the beginning. Thanks.
Thank you, Andrea, very much. I will start sharing my screen. Hope everyone can hear me well. Start sharing the screen, and you should see the screen now. Okay.
Lukasz, we are.
You've seen your email.
Yes.
Really?
You are sharing different, the wrong way. Okay.
But it's like strange. I'm sharing the full screen now, all the time. I don't have, unless there is no way to share the full screen, it's only a browser.
Probably yes.
Okay, sure, that's it. Okay, can you see now my screen?
Yes.
Great. So what you see now is like the new layout of the Datahub, or the technology which is behind the Datahub. What we need to use, how we want to use it, is always to start the point where we can connect, and the connect point for EGI Datahub is datahub.egi.eu. But for demonstration purposes, I will be using my demo infrastructure, which is more connected to more elements of the and give me more freedom during the demo. The release I'm going to present today is the release which is connected to is named 2022, and is going to be it is published available already, but it's going to be deployed on the EGI Datahub in a month or so. So at the moment, the way in our system, if you use our system, as Andrea was mentioned, you need to connect to the you authenticate yourself using EGI authentication, one of the IDP system, which is in this case is EGI checking. So when you're logging to the system, you get your credentials are integrated with the Datahub, and all the roles and the groups you are a member of in EGI virtual organization, SSO EGI, are hierarchically replicated to our system. So in this case, because I log into the case, I log to the system using my account, my true EGI account. I'm a member of several groups, and those groups are presented here and automatically replicated. If I will become I will lose membership in that part. That group is the connection will be lost. This is a functionality which is already there in the Datahub, but this is the key part of the access control right and the security system in Onedata and EGI Datahub as well. Because thanks to the group membership, you can connect other people to your data resources. You can share your resources easily just by using the group memberships and asking the groups, the members of the groups to be a member of your resources. What is new in my presentation, what is new is a completely new integrated interface, which was a transition. We were in the transition for a few last years towards the fully unified global interface, which connects all the services and the application which are running in the world, which delivers me the unified information in one place without jumping between the hosts. And in that case, in my demonstration, I have a few data collection, which Andrea was mentioning, and one of them is the collection which is called Demo Hub. And the collection is supported by 3 providers at the moment in 3 different places of the world. In one of those places, in case on Bari in Italy, this connection is synchronized from the existing NFS system, which is externally managed to the Onedata. So the data can be like inherited a legacy collection into the system. But in case of Lisbon and Krakow, there are 2 different, there are collections, there's a location of Datahub, which allows me to do local processing, read-write processing, caching, and transferring the data between the sites. In case of Krakow, behind the scene, I have Ceph. In case of Lisbon, I have another NFS POSIX, but this time is not synchronized. This time is used as a natural backend to the instance of the provider. So if we have a unified vision of the whole application, now the difference between the previous version and now is like that we have like graphical user interface, which is changing the site. We are changing the sites without leaving the page. At the moment, I'm connected to Bari. This is the place that I'm connected to, and I'm viewing my data collection from the Bari perspective. We are delivering the global namespace, but even though our users need sometimes to choose the sites, choose the places which they want to connect with and they want to work with. One reason, of course, is like latency, to increase the latency, to reduce the latency, of course. And the second reason is like they want to be up to date with the collection, because there is eventually consistency delays between the updates of the collection between those instances. So if you want to be at some certain location, it's good to connect to the particular instance. In my case, I'm connecting to Krakow. And this gives you some overview of the things, how we can navigate and browse the system at the moment. And one of the very important element of our system is the data locality. So we deliver the global namespace. So wherever you go, in the end, you will see exactly the same with some delays, usually it's a factor of 20 to 30 seconds delay. But you want to have a control on the distribution of data in many ways. One of the ways, like you can tell in advance where the data should be located. So I can tell the system, please replicate me this particular file to Krakow. And I'm starting some sort of job. And this job is this file of course was very small, and this job is like telling the system replicate me the whole part of the collection. Of course, I can tell on the single file, do that same thing on the single file, but I can do that as well on the directories, subdirectories, or the entire collection, which of course will take a longer time in the process, longer process time to process the data. I can see the process, the speed of the last transfer, the speed is slightly delayed by 30 seconds. So I can see the history of all my jobs which I created then, and I can monitor them. Of course, these jobs might take some time. Another part is like, of course, when we are when we are moving the data, sometimes the data needs to be delivered on the fly. So the user is not telling the system before when the data is needed. I need this data currently in my graphical user interface in Kraków, and I want to just open the file, but I don't want to tell the system in advance that this file is needed. The system is delivering the data on the fly. This is very important, of course, in case of the POSIX access, not the graphical user interface access, because sometimes this gives us ability to read the data on the fly, even though the data is not yet replicated. But when it's replicated, the next time I will read the blocks which were delivered are delivered directly from the local cache location, and this brings this changes this distribution of data. Of course, when I'm working with small files and needing to read them entirely, the entire data is replicated. But in many cases, it's very often we have large scale computational cases when only part of the files are needed, and the system behind the scenes delivers the low level system optimizes what is needed and delivers the actual blocks which are needed while we are processing the data using POSIX interface. Of course, in case of graphical user interface, you always need to download the whole file, so this is not a very ideal case. But what we recently introduced is another way of controlling the locality. As you know, you can have like the on the fly, so you don't care where the data is, you just read it at some location, like I did it now, being connected to Kraków using graphical interface. I could do exactly the same when I would be mounting a virtual file system in Kraków using POSIX directly to connecting this provider. But there's a second way I can do that by job, calling the REST API, telling me move me data from one place to another. But there is now another way we call quality of service. So on the collection, on the particular file, I can tell the system that there are some specific requirements I would like the files under this directory should be met. So at the moment, I want to tell the system that the file should be replicated to the storage with durability long, which has the long durability and is located in Italy. And the system tells me that currently this requirement is fulfilled. So it means that all the files on the directory COVID and all subdirectories down there are replicated to the storage which fulfills that criteria. So choosing one of the files, I can check data distribution. The data is in Bari and in Kraków. It might be in more location than that. In my case, the storage attributes are defined under the storage definition by system administrators who are configuring the storage. And these attributes might be used later for querying the system and for choosing the optimal locality of my data. In this particular case, in Italy, I have a few storages there. One storage is called 185, and the storage has a few parameters: latency high, durability long, country Italy, and the backend POSIX. So I can use these attributes, these tags, in my query, in my system, in configuration of my system, to define where the locality should be allocated of the data. So I want to make sometimes it more complicated, but at the moment, if you see something like that, of course, these attributes are hierarchical. So they are going down there, and they are in hierarchy dependent from the a set for all the subdirectories, and we are controlling the meeting criteria for each of those attributes. So at the moment, I will try to move the data to this data, the system with another example, just to explain a bit more with this idea. So I have, like, in this directory, this COVID, I have like a settings which requires that all my files should be replicated to, eventually should be replicated to the storage which has a long durability and is located in Italy. But I'm connected to Krakow, so everything what I will be storing, I will be storing at Krakow storage, which has some criteria, but for sure might met some criteria, but for sure is not located in Italy. So when I move the data here, I just drag and drop the files. The file is uploaded and it's stored in Krakow. And when I will do that fast enough, maybe I will manage to do that. Data distribution. Yeah, the storage, the data currently is stored in Krakow, but the rules which I expressed, forcing the system to start the automatic replication to Italy, and in a second you will see the changes will happen there. The location should be there. So that's the idea of having the attributes. It gives us more freedom and more better control of the data locality in the whole distributed area environment. We can tell the system that everything what are created in the processing environments in different distributed cloud should in the end goes to my local storage NFS in my lab or in my data center, which I trust the most. Whatever I create, I need to process that in specific data location. I can tell in advance the system that please replicate me to the respective country. Of course, this replicas might be queries, this logic might be very complex, and I might have more than one replica, more than one quality of service requirements. And in the way what we are delivering for the more complex processing scenarios, you can hook to the event in our system, which will tells you that the specific quality of service is met on the particular directory on the particular file. So that can be used in your processing of the tasks of the files in the remote clouds if the processing requires the particular file should be located very close or the specific location. So you can hook, not only define the location, quality of service rules, but you can hook to the event changes, which allows you to control the process. This is one of the new things I wanted to show you. The new element is the quality of service. But another element which I mentioned before during the Andrea was mentioned in his introduction is like a new token. So we are using in our system tokens it's using very often. We use the tokens for two different purposes. One the token usage is for delegation of my authentication. So this token can be used for mounting the clients or REST calls to the REST APIs, and my identity is passed to that token. So what we introduce now in the version 20 is the new token, new named token, and the caveats. So this is like a way where we can control what is how the token and what the token is passing, what the authorization is passed with that token. So let's make it like an example, demo token EGI Datahub. And this is like the type of access token. When we are creating the token in the past system, you created a token, and was like passing the full authentication altogether, which in some sense might be dangerous. if someone would intercept that token. Now the tokens are, of course, you could revoke that token if you felt that something is not right and so on. But now in this new approach, you can define more precise, more granularity tokens, which can be used amongst our location. So one of the things is expiration. So you can define that the token will be expired in a few days or a few places, a few hours. And next one is a region. So it means that where this token can be used from, or allow or denied. Let's say I will use it from the European Union. And I can tell that altogether, all these criteria must be met. So this is the end criteria. So I can deny some countries like this. So it can be used from European Union, but Poland. Another way is like to more precisely control the IP. So I can tell a specific autonomous system in BGP, so which is more convenient than using IP mask, which is of course possible. So instead of telling the specific IP addresses, I can tell that everything what was issued by INF is connected to INFN. IDP in Italy must be allowed. INFN autonomous system is 137. They were really true pioneer of the internet. They have very low number of autonomous systems, but this is it how it is. So this is like the IP, but now the caveats of where can be token used, but now who can token can be used by who or which service. So I can specify this token is only for connecting to the specific providers, a list of providers, and can be only used for one client. So it means that this token will never be able to use for calling REST APIs, which can mess up with my data configuration of our data spaces and so. So when one client has very limited capabilities, it's only focused on reading on data. But if we are going to the data part, we can tell that this token might only read data. It can't be modify any data despite the low level configuration. Of course, we have like a multi-level configuration of access control rights, but this is another way, the highest possible level. So if I will connect using this token, the user, the client, the REST call, the REST API will not be able to use this token for removing or changing, altering any data. And more importantly, more interesting, I can only tell to which data spaces the user which data spaces the user using this token can even see. This is like a filtering of my rights just and embedded inside the token. So let's say Datahub, and there is a brain scans, or I can make a few directories. In the very precise connection, I can even use the object ID of the data, because each of the data file in our system is object ID. So this is the way how we are creating the tokens, and that token can be used later on for connecting to the one client. And before the demo, I just created a very similar token, which is limited to European Union, excluding PL, and connecting to Demobari, and so on. And I use it on one of my locations when I have already connected to one client. One client connected with the full token, which gives me the full authentication and access to all my data. So when I enter this directory full, I see all my data spaces. I see all the directories and everything what is visible in my specific collection. But if I enter to the limited directory, this is another one client which is connected to the provider using the token with the limitations. And now I can see only a single data space because the token is limited to see this particular data space. This is only a single data space and this particular directory. So when I go there and enter this directory, I only see the directories which are on the list of the token. So it's like I'm filtering the files which are possible. And more importantly, when I enter somewhere where I have a file, I can read the file. Yeah, I have access to this file, But as you see, this token is read-only. So it means that I'm not able to modify anything, or in the worst case, I'm not able to delete the files. So I'm getting permission denied, even though even though I have I have the rights to this file, because I'm the owner of this data space and so on. So this is an extreme example of how you can limit the tokens and how you can use these tokens for accessing your data. In the extreme case, you can even place this token into your GitHub repository, public repository, making some experiment on the Jupyter notebooks on your collections, and limit the token to the read-only, and the users of that GitHub repository will be able to only perform and see specific data collections and specific data files, and will not be able to alter the files ever on the highest possible level. So this is one of the elements I wanted to introduce you. And the last element is I wanted to tell you is a more complicated data discovery feature. So as you know, in our system, we have a possibility to control not only the files, but as well to have a metadata. So in the case, of course, metadata can be attached to a single object or to the directories or to the entire collection. So in metadata you can have basic, JSON, and RDF. Basic is just a key value. It's a simple thing like a color red. So in JSON, in the more complex, you can place the very complicated JSON scenarios, which JSON or metadata, which can be used later on for data discovery on several levels. And we introduced recently a new level of data discovery, which allows us to combine the metadata coming from different data spaces supported by different providers, and putting everything into the Elasticsearch like a backend engine for data discovery. And we could have many backend Elasticsearch engines connected to the Datahub or connected to the zone, which which are combining different data sources. And this is the new button, which will be available in Datahub very soon. It's on the pilot way. We have like a few users who are using that. The pioneer community using that is an ECRAN community, which we work with them. And the discovery button creates a thing which we call harvesters. Harvester is the service which eventually feeds the data from metadata about the data from several data spaces. This is the list of the data spaces connected, and each of these data spaces is supported by different providers, or many of those providers. And the metadata are saved to the indexes, and the indexes are kept on the local instance of the Elasticsearch, and that Elasticsearch is used for building a discovery portal, which is already connected by plugin to our repository. This is the MDR repository for clinical trial from ECRAN, and then you can use this for data discovery, specific data discovery pages, as the data discovery of data gathering in several data spaces. If you look at the indexes which we have, these indexes are in fact fed by the metadata gathered in the distributed environment from the multiple collections. So we have like many collections and many locations where this collection is fed, is supported. And in the end, our system automatically updates, discovers the changes in metadata, and feeds the changes to the Elasticsearch, so the Elasticsearch can be used for the discovery portal. Optional is to write the plugin to the zone, so you can directly deliver the users have a proper rights, access control, and allowing them to see the plugin. But you can of course write your own data discovery plugin. On top of that, we have like a public version of the plugin. So for the users who can be not needed to be logged into our Datahub, they can use the plugin as it is, just for the data discovery. Everything is connected to the zone in the back, but this plugin can be published under different URL, under different URL name, URL address, and advertise separately. So this is the three elements I wanted to focus. The new elements of the data distribution using quality of service, new tokens, more complex way of dealing with the tokens, which gives you a lot of flexibility, and the data discovery feature, which is like a new part of our system, and we find a great interest of that feature recently. Okay, thank you very much for the time, and now is, I guess, like we have some time for the question and answer.